Hello, everybody. My name's Clayton Sminiewski. I'm one of the co-organizers for Cafe Scientifique Twin Ports. For those of you that have been to Cafe Sci events in the past, welcome back. And for those of you that haven't been to a Cafe Sci event, I'll give you a little background on kind of what our organization, what our goal is, what we do, that kind of stuff. So the Cafe Scientifique Twin Ports are kind of purpose is to create a more curious, informed, and collaborative society by hosting free monthly public discussions in science and technology. Our topics are really diverse, and we allow anyone to come to kind of experience the talks, to learn about the science, and then we also have asked people from all over the region to give talks. We've had some really interesting topics, learning about bees, learning about writer who's talking about geologists from Minnesota, which really rang true with me, the background in geology. We don't only do talks, we also do sometimes special events. This last Halloween, we had a science songwriter kind of mashup where we teamed up scientists with musicians, and they created some original music, which was fantastic. We do trivia occasionally. Everything's kind of changed a little bit because of COVID, but yeah, that's who we are. Nate and Dan and Vicky are some of the other organizers. And in terms of kind of housekeeping stuff, I'll reiterate some things that Nate said and then kind of add a couple more things. We're gonna ask that everyone stays muted throughout the talk. And then at the end of the discussion, we will unmute people for questions. If you want to say something, if you have a question, you want to type it out so that way we can get to it at the end. If you go into the chat, it's set so you can chat with either Nate, myself, or Dan. I think it's those three. So if you have questions that you want to just get down on paper so that way we can address them at the end, that's the way to do that. Otherwise, at the end of the talk, we'll open up the chat so that way if you have questions but you don't want to speak out loud, you can type them in there. And I think that pretty much summarizes it. Again, if you want to have your cameras on, that's fine. Have them off. Doesn't matter. All right. And with that, I'll give it back to Nate.
I was muted. Thank you, Clayton. So tonight's topic is data science. This is a really timely topic. We've had multiple people over the past couple of years ask, when can I learn a little bit about artificial intelligence? When can I learn a little bit about data science? When can I learn? And we've had complicated talks in the past. I don't necessarily think that, and by complicated, I mean very mathy talks and things like this. And I think tonight is going to be a really special talk in the sense that Dan is going to be breaking down what is sort of a leading edge subject in science right now. My training's in math, and almost everybody I went to graduate school with are now data scientists. So this is relevant. These are timely topics. These are important scientific and technological techniques. And so really happy to have Dan here to talk about it. A little bit about Dan. So as Clayton mentioned, Dan has been one of the organizers for Cafe Sci for the past couple of years, and super grateful to have his contributions to this team. So he's dedicated to sort of sharing science as a whole. And when the opportunity came to give him a chance to talk about data science, we were really excited. So Dan is a recent graduate from University of Minnesota Duluth with his degree in mathematics and a minor in computer science. And I'll let him tell you a little bit about how those degrees interplay and that training, both of those sort of simultaneous trainings are important for data scientists. And interesting facts about Dan. You may have seen Dan around Duluth playing music at a couple different venues. I know I have, and it's been amazing. So not just a scientist, also a human being. And so we will let the scientist human being take over from here on out. Dan, thank you again for doing this tonight, and I'll hand it over to you.
Thanks, Nate. I'm gonna get my presentation up, but it might take a second. Let's see. And all right, so like Nate mentioned, my name's Dan. I'm trying to move into doing data science work. Just today, I actually finished my last round of interviews for a company, so ideally I get hired. I graduated in May. I studied math and a computer science minor. And then on the side, I actually, with a few other students, started a data science club to do data science and data analytics, because we just sort of felt like that was where math is headed right now as far as the industry. And it's just an exciting time to be interested in math and computer science stuff. So today's presentation starts with a question. So we're going to talk first about World War II bombers, interestingly enough. So in World War II, 97,810 US bomber planes were manufactured during that time. And some of those planes flew upwards of 25 missions during the war. So now I want you to imagine that you work for the US military during this time, and you work doing intelligence work. You know, you analyze data, you're trying to make it through the war based on the information that you get back from the front lines. And so someone comes and asks you and says, our planes need to be light enough to fly fast, but shielded enough to sustain enemy fire. What part do we shield? And so before getting data, you might think through some of kind of the engineering parts of a plane, of a bomber, and say, you know, the wings, the propeller, maybe the cockpit. But really that question about needing just enough shielding to protect the plane so that it returns leads you to gather some data maybe. And let's say that this is your data that comes back. And these shots represent places on planes that return. And so we see a lot of shots on the wings, a bunch of shots between the gun on the back of the ship, or of the plane, and the cockpit, the hull. We see a bunch of shots on the wings in the rear there. And we're thinking about armor is heavy and it's expensive. You know, this is the war. They were trying to make use of what metal they had. And so if we can only armor around 10% of the surface area of the plane, which parts do we arm? And so, you know, the US military looked at this data and they said, this is a real problem, by the way. And they said, well, I think we should protect the tips of the wings and put some on the tail maybe. You know, they had a response like that. But there was a Columbia University statistician named Abraham Wald who worked on this problem. And he came back with the exact opposite answer, and I will tell you why. So he said, let's imagine that we have our planes being sent out, and here we have 18 of them. And then these are our returning planes. And we see that, you know, 6 of the planes returning had sustained mostly wing damage from, you know, anti-aircraft guns. And then 7 planes mostly had tail damage. And, you know, again, maybe you would assume, okay, around half of each. So maybe we split the armor on those parts of the plane. But what he pointed out is that we're trying to predict what it means, or what part of the plane gets shot at that makes it so that the plane does not return. And so he actually said, looking at this data, we're missing shots near the cockpit of the plane where the pilot is. We're missing all the shots on the propellers, which would send a plane down. And we're missing it in some pretty vital spots on the plane. We're missing data. And so he basically said, or he came up with the idea of what we call survivorship bias, which is data sampling that is biased towards instances of an unfavorable event not occurring. So in this instance, that's the plane not going down. So we were looking at data from all of the planes that returned, and we need to figure out, okay, what is making the ones that we don't see not return? That it's important to note, really, that the data is not necessarily false or fake, but it can be interpreted incorrectly. So there was no lie anywhere in that. It just was a situation that sort of led to some false assumptions. Survivorship bias has a few other examples that are pretty common. One is people always say appliances were just built better back then, which, you know, could be true or not. But what we have right now as evidence of that being true is just all of the appliances that have, you know, lasted since the 80s or the 90s. And it's 2020 right now. Anything built today will have to wait until 2050 or 2040 to get the same experience. So all of the washing machines and dryers and things that didn't make it aren't around as evidence that they didn't make it. Another current application of this is people saying that they got the coronavirus and didn't have symptoms. It's not as bad as they make it out to be. I had a very real tweet of this that I thought about putting in here, but I just think not making it political is a good idea. In any case, this is a very common ideology surrounding certain diseases or disasters. When people survive, they tend to downplay the situation because of their own survival being the only evidence that they have. So that leads me to kind of my first point of today, which is that we live in a world where real life data is dirty. People talk about cleaning data. If you're a data analyst or a computer programmer, that's a pretty relevant thing. But what I mean by real life data being dirty is that it's full of inconsistencies, errors, and it doesn't really follow any clear-cut patterns. Everything that you learn in school about statistics, about numbers, doesn't exist to the same degree in real life data. Some examples of, if you're working for a company, you know, people typing in their email addresses, they might type in something like whatever email address at gmail.co. And if your website or your app doesn't pick up on that, then you in your database have a line that is listed as that. And then down here, I put the chaos of the universe, which is just that in stats and in class, we always talked about these neat distributions and how things are kind of approximately that. But I would say that they really are very approximately that, if not that at all, because real life data is just kind of all over the place. We have all sorts of outliers and things like that. And so a lot of what people that work with data spend their time doing is turning that data into something that is actually able to be worked with. That's kind of the first step. So another example of sampling bias compared to like the survivorship bias that I was speaking about earlier, maybe a simpler, more straightforward one is, let's say that you have a population of red dots. I mean, this is our bin right here, or not of red dots, of dots. This is our bin of dots. And we collect a sample of them because we can't get all of them. Maybe there's a lot of them. There could be, I don't know, hundreds or something. So we use those dots to try to make an approximation about like the ratio or the number of each kind of them in the actual, this blue bin here. And so we count our sample and we say there's 5 red dots and there's 5 green and there's 2 yellow dots out of our 12. And so we can just take our fraction and neatly multiply it across. We can say there's 12 dots of what we think is maybe like a 50 dot population. And so if we multiply by around 4, we should get what the actual, close to what the actual ratio of them is. But if we look at what our sample is like compared to our population, and this is kind of how sampling is like in real life. It's not always as biased as this, but it's just not a good cross section of what our population looks like. We see that, you know, there were around 20 red was our estimate, and that is twice as many as the 10 that are really in our population. Around 20 green is far less than the 36 that are actually in our population, and around 8 yellow is twice as many again. So that's an example of sampling bias. And I want to talk about a real life example of this. The 1936 election was between Franklin Roosevelt and Alf Landon. And at the time, you know, politics was sort of headed in a data-driven direction where people were asking, how can we predict who's going to win? How can we predict what states, you know, you need to be campaigning in? And so there was a poll conducted by the Literary Digest, which was one of the most acclaimed polling papers at the time. And they did this thing. It was kind of a new thing for them. And they took 2.4 million mailing addresses that they got from phone records. And they sent them mail-in surveys that said, who are you going to vote for? What issues are important to you? Things like that. And they took all of those responses and they logged as many as they could. And they had just like the largest survey that had happened in American history to that point, I would say. And they came to the conclusion that it'll be a close race. Alf Landon will win by a small margin. The exact percent, I don't remember off the top of my head. But that ended up being just so far from the truth. I mean, if you know American history, you know that Franklin Roosevelt beat Alf Landon because Alf Landon is not a US president. Roosevelt was reelected by one of the largest margins in US history. So that poll returned results that were about as far from the truth as they could be, even though the sample size was 2.4 million. A fun fact actually about this was that George Gallup, who does Gallup poll, if you are familiar with the name, that's like the source of the name for it, at least the foundation of it. He and his team properly or correctly guessed who was going to be elected president, and by a pretty close margin with just 50,000 sample points. But they got their sample in a more cross-sectional way. It was more representative of the total population in the US at the time. So some mistakes that they made is that in 1936, home phones were new and they were prohibitively expensive. So the people that they were polling were people that had phone numbers in the US at the time. And those people were on the wealthier side of the US population distribution. So that kind of skewed the results some. And then the other thing, which is a different type of bias, is that mail-in ballots or survey responses, excuse me, I wrote that wrong. But they attract only strongly opinionated responders, meaning people that are willing to fill out the survey and send it in feel more strongly than necessarily people that will show up on election day. So they got a cross-section of the people who had phones that were on the wealthier side, maybe, that were strong enough opinionated that they would return a response to a survey, not a good cross-section of who will show up on election day in 1936. And that brings me to a point that people have said a lot, and I think I need to reiterate a couple times tonight almost, but it's this idea that if you torture data long enough, it'll say anything. And here's an example of that. 9 out of 10 dentists recommend Sensodyne toothpaste. I'm sure all of you or most of you remember seeing a lot of toothpaste advertisements in like the 90s and early 2000s where saying 9 out of 10 dentists or things like that. And where that actually comes from, because that can't be false. False marketing is illegal in the United States. There are laws that prevent it. But what it comes from is asking questions like, which toothpaste brands do you recommend? And allowing people to check as many of them as they want. And so 9 out of 10 dentists said that they would recommend Sensodyne, or they said Colgate at the time, or whichever one, So that's not technically false, but it is very misleading. And all sorts of different marketing strategies like that exist in the United States to take advantage of that the US population, takes those things for granted, doesn't necessarily understand where the data is coming from. So definitely misleading. So that brings me to the present day. These are all examples from the past. And those were kind of examples of statistics in action and sort of like business intelligence, politics. We're at a point where we are generating, this is 2.5 million terabytes of data per day, which was in 2019. And to put that in some context, because you might not understand how big a terabyte is is around 500 hours of HD video. So, I mean, we're generating a pretty gigantic, collection of data on the internet, to companies that are collecting data from our phones, all sorts of things like that. And part of why that is true now is that we're at a point where data storage is decreasing in cost. Every day almost. This is on the left, we see the cost per gigabyte of hard drives. So that's like your personal computer. This was a graph generated by Backblaze, which is a cloud computing company. But then over on the right here, we see the current prices for data warehousing and storage at Amazon. And this is yearly. This is 23 cents or 2.3 cents per gigabyte for storage at Amazon. Or, this is pretty crazy. For archived data storage at Amazon, we're getting less than 1/100th of a cent here. And so what we see happening is just the price of data going down, the price of storing it. And so these companies can collect more and more data. The government can, just Joe Schmo who has a bunch of money can collect data if he wants. Politicians, all these groups can collect data, and they can store it for just about as long as they want. So sort of a new field comes around, at least in our story here tonight. The confusing thing is that data science by name gets mixed up with a lot of different fields and different jobs. And so it's kind of a cross section between data analysis and statistics, some like business intelligence kind of things, and machine learning, which I'll get to in a second. But it's about asking the question, we can have any data we want. We can store it for as long as we want. We have more ways to collect it than ever before. how can we make that valuable to us? And all sorts of big companies are able to spend the money to turn that data into money, into power, into all sorts of things like that. Machine learning, I wanted to quickly go over just because not everyone necessarily knows what that is, but it's basically just these new computer algorithms that allow computers to diffuse information from data, or to take a huge data set and say what is important for us to see in here. And I'll get to some of those in a little bit. I wanted to run through a few of them. And so the first thing I wanted to talk about is what the section I called the good, because I wanted to do like the good, the bad, the ugly. But this is the good. I think that these algorithms are really cool and impressive. And so the steps to this machine learning process involve gathering data, which could be taken in from your phone, could be taken in from social media. We gather weather data all the time. We gather data about, fish populations, just about everything you can think of. There's some way to gather data about it if you want to know more about it. And then that process earlier I was talking about of cleaning the data is where we take the data and we sort of manipulate it so that our computer can understand what it is. If it's a number, it needs to know that it's a number. We do some sorts of normalizing our data, which is something I don't necessarily want to go into too much. But there's all sorts of pre-processing steps to take this data and turn it into something that our computer can play with. So then the next step is building a model. You either let your computer do it on its own, which is called like an unsupervised learning model, or supervised learning is basically you are there the entire process and you sort of cater it to meet your needs. But you build the model and then you test the accuracy on known points. So on the data we've gathered. And then the whole point of this process is that we can use that model to predict unknown points. And as we're predicting unknown points, we can keep gathering more data, and the loop just kind of keeps going until our model is so much better than when it started that we can roll it out and have it on, the iPhone or whatever. So the first one I wanted to talk about is one that most of you have probably some familiarity with, but I thought I would go over it. It's just kind of the easiest one to talk in depth about, and that is linear regression. So let's say we have a bunch of sample points here, these blue dots, and we just, in this example, we just have two different measures about it. We have our predicted variable, which could be anything from like price to like the weight of humans or the speed of cars. And then our independent variable we're using to predict it. And so the whole point of linear regression is we want to be able to take a data point or an example of something that we have this variable about, the independent variable, and predict the predicted variable without having to actually measure it, because we can't always do that. So then what this comes from is using an equation that, again, a lot of you are probably familiar with because it just looks like the equation for a line. And that's where linear line comes from. So that's this y equals a plus bx. Our x is our independent variable that we're using to predict. And the b is some coefficient, some multiple, so that'll make our line steeper or more flatlined based upon that. But then the way we measure if our model is a good fit for our data, and I only left 2 data points here, but remember it had this big cloud before, and you can see that the line is splitting it about half above and below. But the way we measure how well our model fits our data, in this case, the linear regression that we did, is by using 2 different things. There's a bunch of ways to do it, but the 2 main ones I would say are residuals, which is the distance between estimated value and true value. So our estimated value is this red line, and the distance vertically is the residual, sort of the closeness of fit of our model to those specific data points. And then we can calculate, because we've got a whole cloud of points that we're doing. We don't want to just see every single point. We could have millions of them, We have what's called an R-squared value, which is this formula down here. And I won't go too much in depth about it, but it basically just sums up those residuals in a way where 1 for an R-squared value means that 100% of the variability in the data is accounted for by the model, and 0 is 0%. So we want our number to be relatively close to 1. So this is an example of this model being used. I don't have examples of every model being used that I'm going to talk about tonight, but this is just a simple one to crank out. I used R programming to do this. So this is a data set that talks about, or that has information about cars in the 1920s, their speed that they're being tested at, and then the stopping distance at that speed. And so we have all of the different kinds of cars. And so we've got all sorts of different points happening everywhere all over here. But we can see that there's a general trend upward, which makes sense in that the faster you're going, the longer it takes you to stop, the further distance in feet. Looking at the measures of fit, because we don't want to just draw a line randomly through and say, well, we think it looks like it's going upwards. We have our residuals versus our fitted values, which is just kind of random. That just basically is saying, like, if we drew our line and it went above all of the data points, then we're going to see a pattern over here. And if we cross it a certain way where on the left side, these values from from 0 to 15 are getting underestimated and the other ones are getting overestimated, we would see a pattern in that way. And then our multiple R squared value is 0.65. And honestly, for real world problems, that's pretty insanely good. So I as close to 1 as you can get is great, but a number like this is more accurate to the real world because we just don't have perfect data. We don't have our points in a straight line in the real world. Some other regression models, multivariate, which is just we take our linear regression and we put it into multiple dimensions. We have our beta values go for every single X. So we could have a million different factors that are contributing to it, which I can't make a picture of, but that's possible. And then the logistic regression, which is sort of, instead of predicting a number like what our stopping distance was, we have a model which predicts whether a student will pass or fail. So that's predicting like a yes or no situation. And you can see this, this sigmoid curve here, I think is what that's called. But basically just this upper end, this 1 means they pass, 0 means they don't. It follows a formula that is kind of close to the linear regression formula, but it's not super important. In any case, there's a lot of different versions of regression. Regression is a pretty common idea, and there are a lot of different, what I would say are flavors of it, and some cool applications too. So the next thing I want to talk about really briefly, I'm going to try to buzz through these because this is the nitty gritty, but I think these things are cool. That's like what gets my brain going a little bit. So this is K nearest neighbor classification. A classification algorithm is like, let's say that you have 15 different types of beans, and you can measure the length of the bean, and you can measure the weight of the bean and the color and things like that. So then you have all these different characteristics and you put them in either a 2-dimensional plane or a 3-dimensional plane. And classification is basically just taking any bean in this situation based on those measures and saying, what kind of bean is it? Which one is it closest to? So K nearest is really simple. The idea is we take a data point and we say, what are the K nearest, the number K here that we pick, we just pick a number. What are the K nearest data points to it? And which bean do we think it is based on that in this example? So we can see if we pick K equals 3 and K equals 6, that we'll get, we'll classify this gray point here as red because it has 2 red points that are close and 1 green. Or if we go up to 6, we would get green because we have 3 that are green and 3 that are not, but green is the majority there. And then like the regression model where we have measures of closeness of fit, we have just kind of a question about what % did we classify correctly and what did we classify incorrectly. And based on that, you would take your K and you would adjust it or your features to try to make it so that your points are getting classified correctly. A cool example of that I myself did not build, but that you can go check out online is image classification of cats versus dogs. There are all sorts of image classifiers that exist already to get information about, okay, this spot on a picture, is it fluffy? Is it light? you know, like white versus black or brown. And then based on that information, you can use this k nearest neighbor algorithm, which is pretty simple. I mean, I hope everyone followed it. It's hard for me to answer questions right now, but based on that, you can kind of cluster the dogs versus the cats in two separate corners of our space that we're mapping in. So then the last classifier that I'm going to talk about is decision tree. Let's say we got a video of a pet cat or a dog. And what it's going to end up being is like a taxonomy tree almost. I drew it out in advance, but how the computer runs through it is it builds this tree slowly, and I'll explain in a little bit how that works. But for example, if we have a video of a pet cat or a dog, and we have some information about it, we could say, well, if the animal is under 70 pounds, and we'll say true is over here on the right and false is over here to the left, then we would say dogs and heavy cats are going to be over 70 pounds. And everything else is going to keep going through our tree to get reclassified. So if in the video it meows, then we're going to say, you know, the noisy cats are going to be put in one corner because we know some cats won't meow, and we know that dogs probably won't, but maybe we'll get some weird dog that can meow, and that'll go in that category. No classifier I would say is 100% accurate. If that happens, that means there's something wrong. We get a situation where, you know, the animal in the video eats dog food, and somehow our machine can tell. If it eats dog food, then it's probably a dog or a cat that has kind of weird dietary interests. And then, you know, it just keeps going and going through that to fill out the rest of the tree until every single animal in a video that we've got in our data set is classified. So then what we have is a tree with a bunch of rules that we can use to classify future videos. That's the whole point of doing this. So how the computer builds this, because decision tree is not one that you yourself build, but it's using a process analyzing information gain and entropy, which I am not going to put the formula on the screen because it's just too hard to explain. But I invite anyone who's interested to read about it because I think it's very interesting. Basically, it's just entropy, if you know from chemistry or from physics. It's just like a measure of chaos and disorder in the universe. And so here in our computer world that we're working in, what we want is for every split in our tree to decrease the entropy of our system, decrease the entropy of every single point on our tree as it breaks down, so that it's neat and orderly and our computer can separate it more. And so the computer will try, you know, hundreds, if not thousands of different combinations of this in order to measure and figure out which next step decreases entropy the most and provides the most what they call information gain, which is just a measure of what do we learn from this separation, sort of. A really crazy thing that can happen then is we can use classification with regression. And regression, if you remember, I was talking about earlier, was an estimation of a number using a formula. And so we have a situation here where the classification decision tree is used to model which different regression should be used. This is here, it's just doing a basic number estimate. It's using mean, but basically you can make decision tree regression where every single node at the bottom of this tree, every time it says, well, is it sunny and windy, true or false, you know, and figure out which regression model to use and then have an actual model there. And so that's where it gets a little bit complicated, is that these algorithms can all be used together. And I don't want to say most, but in many instances of actual applications, they are used together and built off of each other because data just doesn't coerce itself into one regression model that tells us all we need to know super easily. The last model that I want to talk about, just because, you know, there's so many different models you can do. There's so many different ways you can load your data in and change it and spread it out and, you know, all sorts of different stuff you can do before you put it in the model. But the last one I want to talk about is kind of where we get into what people call artificial intelligence. It's neural networks. The idea of it was based off of neurons in your brain. and the way that they fire and communicate with each other. And so when a node in this neural network receives a message, you know, a data point or a collection of data points, or, you know, there's all sorts of different things that these nodes can take as input. It fires off and sends a specific message or data point or model to any of the points in the next layer, and so on and so forth until we get to the output. And what's kind of crazy to know about neural networks is that they are what fall under what we call black box or unsupervised learning, which means we don't exactly know how the neural network gets to the intended output. We just know that we told it, here's our input data, here's what we want for our output. You know, we want you to predict something to the best of your ability. And the computer just comes up with its own way of doing it, using all of these different techniques that I was mentioning earlier and more. So it's pretty insane in that way. And that has some very cool and very, very powerful applications. So I'll just run through a few of these really briefly. We can identify high probability cancerous tumors by measuring their length and their width and all sorts of things about them, their coloration, because our computers have gotten pretty good at measuring those things. And the models of those are pretty reliable. That's a good way and very competitive way, I would say right now, to tell if a tumor is cancerous. It's also being used in the same way for things like disease identification in people. So knowing if someone is predisposed to things like diabetes or if they have diabetes, all sorts of things like that. You know, we're playing as a species, as humans, we're playing with this idea of using computers to identify those things because we can sometimes get them to have a better rate of identification than an actual human doctor. Some other ones, it's really common to use machine learning techniques or algorithms for things that humans don't want to do. No one wants to spend all of their time looking at pictures of the ocean and waiting for an oil spill to happen. But we have computer systems in place, and a lot of the oil tycoon companies do, you know, that check satellite imagery or images from their video cameras, and it will like send out an alarm once the computer identifies an oil spill. And so an algorithm is being used to separate from random cloudy ocean versus an oil spill. Another, no one wants to read all your emails, and I don't think anyone wants their own emails read by everyone or their own calls screened by some real person. But we have algorithms that can spot spam emails based on their text contents and calls based on the location they come from. If they are like a mock-up of your own phone number and things like that. And then, I mean, the biggest one that, and this is a little bit frustrating for me personally, but a lot of these algorithms are mostly used for predicting economic activity, for investment portfolios, for banks, and for real estate, for the wealthy people of the world that can afford to use it to make themselves more money, which is very cool and impressive, but I don't always find it as interesting. But anyway, now we get into the cool stuff, the bad and the ugly. And there's all sorts of different examples of this. I kind of lumped them together because I think that in my mind, when data science goes ugly or goes bad, it's usually negligence, but it's not always. So let's talk about another example. Let's get into another talking thing here. So we have, let's say that you are Amazon and you are trying to hire some people, and you have, I don't know, you might have 3,000 applicants for a software job or something. So you have too many applicants. You can't read all of their resumes. You can't just throw out a portion of them. I mean, that doesn't seem like it would give you the best result. You could be throwing out the best candidates. So then what do? Do you read them in order? I mean, it's hard to think about. And someone comes to you and they say, you know, I can make this computer program, or I have this computer program that can take your resumes and the applicant info and put it in a computer. And then it can give you only the good workers, only the ones that you want to hire. And they say, I know that I can do this because you have all of the data stored, all of the information saved from every time that you've hired someone for the past 10 years or the past 15 years. And then going forward in the future, we can take the information about who you hire from what the actual computer gives you and put it back in the computer to build the model even better. You know, this is just great. It sounds good in practice. But then let's take a look at this. Let's say we've got our training resumes. These are all the people that have been hired or been given interviews in the past 15 years, maybe. And they were used to train this computer, this program here, to output the resumes that match the same cross-section as what the initial training data was. And so if we input our new resumes into the computer, we're going to get something that generally looks like this, you know, because that's what we told the computer we wanted, basically. We said, we want data that looks like this. We want resumes that look like these. We want people or candidates that look the same as this. And that sounds great. I mean, if that's who you hired in the past and that's who you're looking for right now, that sounds good in practice because you don't have to read 3,000 resumes every time you want to hire anyone. But then let's think about, let's say those orange dots there are our women candidates or our notably female candidates, and around 92% were men because it's a tech company, you know? And, you know, if we have data for the last 15 years, it's likely that at least in the 2000s, we were biased towards men. But I think just in general, it seems like tech is more men than women anyway. So if we train our model to do that and we do not pay attention to what we're doing because we don't know how the computer is doing it, we're using a neural network, we're using some sort of black box modeling, no matter what our resumes look like going in, our computer has a chance, if that was our training data, and that's what we told it to do, it has a chance of picking 92% men and 8% women for candidates, even if that's not what the demographics of our new population look like. And that's a very real story. And it's very scary to me because Amazon tried to build this tool that was going to be used for recruiting. And they said that they didn't lean on it. They didn't use it solely to inform them. But it's entirely possible that they did. Really, what's scary to me is that they didn't even include the person's gender in the data that was put in. It's just that instead, the technology favored candidates who described themselves using verbs more commonly found on male engineers' resumes. And those sorts of, we know that those sorts of differences exist in our world, but to see a computer point them out and then use them to hire men over women is kind of crazy to me. Even scarier, some 55% of US human resources managers said that AI would be a regular part of their work within the next 5 years. So that was in 2017. They said that. We're in 2020 now. I imagine that a good percent of recruiters are using software like this. And it's hard to know based on the output simply from what you're putting into this program, whether you're getting biased resumes selected coming out of that. And that's what makes this such a hard thing to think about, is that if you're using unsupervised learning for something that you can't identify particularly well if it's working or not, you're trusting a computer to do something you haven't necessarily told it to do that well. So let's talk about another example that's pretty insane to me. So target advertisements have probably shown up at a lot of your doorsteps, or you know someone who gets target ads all the time, coupons, things like that. And what's really interesting about target ads that I didn't know for a long time until I read up on it was that what happens is Target gets you to either get a credit card or you use whatever credit card you have at Target. And they have an ID that corresponds to who you are, your identity. Usually they have some sort of email associated with it if they've sent you emails before. They have you as a person in their system though, and they know everything that you have purchased because they can store that data. It's so cheap to now, and it makes them money to do that. But then they use that information to print you your own personal coupons or advertisements and send them to you. So when you get Target ads at your house, they are catered to your house and the people that live inside it. And there's no one at Target who's sitting down and saying, me, Dan Crist, saying, Dan is going to buy such and such things, so we should send him these advertisements. Their computer system is trained to do that, and they know it works because it's making them money to do that, so they continue to do it. And that's a little bit creepy, but where it gets creepier is Target says, what purchases are predictors of times when customers should receive targeted advertisements? You know, we want to send out packets of ads or of coupons, and we want to be making money. But it costs money to print all these things and to run the computers and to store all the data. What are important things for us to watch out for? You know, what should our computer systems be watching? And one really, really crazy one that was in 2012 was that Target figured out how to predict if people were expecting or if they had given birth recently to a kid or not. This is a true story. Target started sending targeted ads to this house with two parents and their daughter that were for baby stuff, and it was sent to the daughter's name. And the parents got really upset, and they went to Target, and the dad said something about, you know, this is so rude that you would imply this about my daughter. And then later she owned up to that she was pregnant, and Target's computer system knew it before her parents did. So pretty insane. This is a quote from the Forbes article where they were talking about the guy who designed the actual algorithm. But he was able to identify about 25 products. One of them was unscented lotion that people buy when they're expecting a kid. And then they get a pregnancy prediction score, which the computer uses to decide, should we send you know, baby ads to this person? Should we be trying to sell them baby clothes or maternity clothes or things like that? Another one, just to briefly go through it, but Siri and Alexa, anything that you say, hey Siri or hey Alexa, where your voice wakes up something, they have to have training data to train those devices to recognize your voice. And the way that they do that is that every time you say, hey Siri or hey Alexa, at least for a long time, they would record what you were saying because they wanted to improve your experience. And it doesn't take much work for them. You know, they can save you saying it that many times and then use it to retrain the algorithm. But there was some weird stuff where Siri, I think, I don't remember if it was Siri or Alexa, but one of the things that they were realizing, the people that were working there, checking to make sure that the algorithm was mostly identifying when you actually said the name of the device, was that the next highest indicator for the phone or whatever to open up was the sound of a zipper unzipping, which leads to some pretty uncomfortable situations. A whistleblower I think at Apple made a big statement to the press talking about that they spent most of their time looking at actual information about people that had been logged, about where they are, their contact information in case there's some issue with the way that their device is working. And then this random 6-second or 5-second video that the phone thought was them saying, hey Siri, you know? So pretty crazy. The last one I want to talk about before I kind of loop back to just like the greater idea of what these algorithms and this big data and all of that crunching means for our society is Twitter and social media are really, really, I think they're more powerful than people think they are. And it's not a new thing. Almost all social media is entirely public data and it cannot be permanently deleted. You can delete it from the websites, but there are archives for just about every single social media that exists. Anyone that wanted your information while you were on the social media and they like wanted it while you were there can have logged it somewhere and kept all of that, and they can have that information on you for forever and they can use it for what they want. There's no laws that prohibit it. So web scraping, which is pretty simple using JavaScript, and then bot training on what I would say is just the world's largest English language data set. So if you want to make bots that speak Twitter speak or tweet, you have the largest collection of tweets at your fingertips. And I personally, for this presentation, tried building a Twitter bot and got my Twitter bot to work by scraping tweets and then kind of building them that way. And I gotta say, it's much easier than I thought it was. So thinking about people that have actual money to invest into that, and computers that are more powerful than I'm on a MacBook right now, they can really do some powerful and crazy things. The Pew Research Center estimated that 66% of all tweets linked to popular websites are likely posted by automated accounts. We don't know that number for sure because we can't, no one says this is a bot in their bio, and that's like how we know they're all bots or not. But there's suspect activity. There's a really interesting study from 2015 where they estimated that I think 12% of Twitter was just bots, and Facebook estimates that more than 5% of its 2 million users are bots. And these are companies that, I would love to see them be bastions of good, and I don't necessarily think that they are. Twitter and Facebook would lose a lot of money if it came out that a higher percent than this was actually bots, because most of their money comes from ad revenue. And so if their users aren't real, if they are fake, and they probably know if they are or not, but it's not public, then that would be a big money loss for them. So I didn't really write out the conclusion super well. Before this, I just wanted to say, there's a lot of really powerful things that we can do with these algorithms. We have so much data. We have much faster processing. We have all sorts of cloud computing things we can do where we can separate these algorithms out and make little parts of the work happen on all sorts of different machines at the same time that communicate with each other. This is like really an age where we're unlocking all sorts of secrets about the world. But at the same time, in the hands of people that are using it to take resumes and read them, and they're not thinking about what they're inputting into this system that doesn't know right from wrong, that just knows what you tell it to do, you end up with some pretty adverse results. So in conclusion, remembering our survivorship bias that I was talking about earlier with the plane, which data science projects are flying and which are the ones that are crashing that we'll never hear of, because a lot of this right now is in the hands of corporations that don't necessarily want it to be public. So that's all I've got for a presentation. Thanks for listening. I'll open for questions if we can figure out how to do that.
Awesome. Thank you, Dan. All right, so we'll go ahead and so you can use the chat. I'm gonna try to open up the chat right now for everybody. So you can go ahead and type something into the chat if you'd like to. You can unmute your microphone if you're unsure how to unmute yourself. When you put your mouse over the main viewing window here in Zoom, in the bottom left, there's a microphone icon, and you can click mute on that. That's one way to do it. Yeah, let's go ahead and open up the floor for any questions for Dan.
Hey, I'll ask a question. This is Tom.
Go ahead. Hey, Tom.
Thanks for your presentation, Dan. It's really interesting. And as a data scientist, and you graduate and go out in the world, who are you applying to? And I don't want to ask what your specific job you mentioned, but what types of positions are you looking for, and what do you hope to do and want to do?
So I think that the end goal for me is sort of, I'm more interested in using this kind of technology to help with healthcare stuff. Being able to diagnose diseases is just something that is like very powerful. I would like to see data science type tools used in like pro-environmental ways, being able to protect the environment, or, like when I was talking about the oil spill thing, that's really interesting to me. But unfortunately, a lot of those applications are really, really complicated. And so for someone like me who's just graduating from college, I can't like just go jump into that spot and make that happen. But I think that for me, I see it as a powerful way to benefit the world if we use it for things like healthcare, for the care of people, not the making money from healthcare, or the environment, stuff like that. Thanks for your question.
Thanks.
Well, I've got a question.
Yes,
Um,
Nate, what's your question?
so, I mean, one of the major things you brought up here was sort of this idea of, and I think about this quite a bit in terms of like sort of crafting a particular outcome, right? Like if you're sort of going in, I mean, it's something I know that comes up in statistics, and it's if you have an expected distribution that you're trying to fit, if you have a model that you're trying to fit, you're already sort of constraining your world somewhat to say this is the outcome I'm sort of expecting. Does it fit this outcome? Yes or no? Here's another outcome I'm sort of expecting. And you hinted on about this a couple different times in there, but I'm wondering, like, you know, besides like, I'm wondering if there's like, and I know there's techniques to potentially get around this stuff, but like something like the Amazon resume, you know, process that you talked about, which is, you know, I've heard recently, like many places are going to sort of like initial screenings where they just take the text from your resume, and if you hit a certain number of keywords, you make it through the next step, you know, and this is how it goes. And so I'm wondering about techniques or ways, you know, if there's anything to sort of move past that, since we know that there is sort of bias involved in this, or if that's just sort of the next, or if that's just sort of something that people are becoming aware of and trying to avoid, I guess, moving forward. So succinctly asking the question, for these unsupervised learning algorithms, or some of these outcomes where you're sort of crafting a particular output, are there algorithms that are being developed, or new techniques, since people have become more aware of it, with examples like the Amazon sort of resume scraper?
Yeah, sure. So I guess what I would say about that is that a lot of the what I would say is like the front line or the cutting edge of those kinds of questions, you know, when they're trying to make a better product like that. I think that I would say that is probably happening right now, that someone is asking that question and working on it. But as of like a few years ago, there was no answer to it. There was no way to separate the unsupervised learning model from including things that we didn't want to necessarily have be included in there, without just checking it every time that it outputted stuff to see if it was a proper sample of our original population of resumes, for example. So what I would say is I imagine that that is happening, that there is research about it, but I have not seen it published, and I don't know that I would anticipate it being public anytime soon. I'm sure someone is trying to sell it if they found it. So
Thank you.
thank you.
I also have a question for you as well.
Yeah.
So it sounds like the data science in general is like an extremely powerful tool, and you have the tools to kind of manipulate data. And like you were saying, you created a Twitter bot with like pretty like limited time. Being that you went through like undergrad to get this knowledge to be able to do this, and the kind of nefarious ways that you can use this information, are you required to take any sort of like ethics class or anything in undergrad?
That's a very good question that I wish the answer was yes to. I would say, just like as a caveat to that, that I studied math and I studied computer science. And while we talked about data related questions and we had classes related to that, you know, we didn't ask these specific ethics questions in class because I sort of taught myself this outside of the classroom mostly. So I think in programs where they talk about algorithms like this, there are probably ethics covered, because there's just such a fine line between picking resumes that are good for Amazon, like we were talking about, or just picking ones that are a cross section of what it used to be like. So I would say no. For me personally, I would hope that other places, other schools are doing that.
Thank you.
Looks like we had a question in the chat. The question is from Vicky, and the question is, if you can interpret the data in a lot of different ways, how do you know you're right enough?
So I think earlier talking about, the quote that I was trying to get at, the one that I was using, was that if you torture data for long enough, you can get it to say anything. And that's really what it comes down to, is torturing it. Because usually the conclusions from our data are pretty obvious. You know, we have our statistical tests, we have different ways we can put our information in a context that makes sense for whatever domain we're working in. But I think it was more just about that at the end of the day, if you want your data to say something or be persuasive in some way, you can sample in a way that benefits you. For example, you can be Fox News or CNN or whatever, and you want your poll to say something. And so you phrase your poll in a certain way and you post it on certain sites or contact people who you suspect will respond to it in a way that you like. And ethically it's wrong, but it's easy enough to do that a lot of the data that we're given, despite being true, not being false data, you know, is very misleading. That's what I would say about that. I see another question. In regards to using neural networks for the diagnosis process in healthcare, would safeguards be put into place to limit bias and make sure symptoms are not being overlooked, especially when considering many conditions present themselves differently in people of different genders, races, etc.? That's a very good question. I actually have a friend who is going to grad school to study this specific question. He's looking into the ethics of using computers to diagnose in healthcare. And what I would say in response to this is that there isn't a point in the near future at all. I don't think there will be a point as long as I'm alive where computers are the only thing being used to diagnose someone. It's just, it is helpful from a healthcare provider standpoint to be given information from a computer that can point you in a direction. But at the end of the day, no healthcare provider is going to remove the doctor or the person who's caring for the patient, because studies kind of say that that doesn't work, you know, that having a doctor in the room is what makes people feel like they're going to get better instead of just hearing it from a computer. So I think if we got to a point where the computer was the only thing, where the neural network was the only thing diagnosing, then safeguards like that would have to be put in place. Absolutely, 100%. But for now and for the near future, at least, I would anticipate having a healthcare provider in the room at the same time. Thanks for the question.
So one question that comes up that I think about sometimes with respect to modeling in general. So whether it's a statistical model or some other model that you've got, it's sort of the flip side of things where we see that like sometimes it's like these models give you insights about things that are sort of startling, where it's like, oh, you've classified all these things in this way, or oh, you've gone ahead and filtered this down so that you're only looking at candidates that are from this particular subsection. And one of the things, this is maybe more a comment and feel free to add in, one of the things that comes to mind to me is that in some ways these actually add transparency to certain scenarios. So the fact that you are actually running things through algorithms and you can go through and you can say, you know, this is my expectation, and you can use this to say, because I think that sometimes when we think about models in general, like we all have our own models for how we're doing things all the time. And they're not necessarily these transparent things where we can go through and say, this was the decision that was made, this was the decision that was made, and so forth. And so thinking about it from that aspect where you can use models to sort of highlight potential biases and things like that and add transparency to a process is something that I've come to think about a little bit more, as opposed to, you know, the constraining side of things where it's like, oh, this is the model, you know. And so I don't know if that's something that you've thought about, or something that has come across you when it's like thinking about, oh, models sometimes actually add transparency to these scenarios, even though they are, you know, yeah, I don't know. Just sharing a thought out there that
I definitely agree with you on that. I mean, so beyond just modeling, I think thinking about the world through like a statistician's lens is something that kind of shines a light on all sorts of different things that I wouldn't anticipate finding out in the first place. An example, when I was doing this presentation, I was looking at the survivorship bias, and I was looking at like examples of that because I knew about the plane one, and I knew about people saying, you know, polio wasn't that bad, or the flu wasn't that bad, or things like that. But I didn't, you know, my entire life I had heard people say that things were built better back then. And I think that there probably is some evidence of that, but it's also shrouded by just this overwhelming system we have, where what we see right now of the appliances we had from the 90s or the 2000s, you know, those are examples of something that isn't actually the entire population. So I think that models and statistics and things like that, though they can be used to mislead, sometimes when you're going through this process and you're breaking stuff down and you're looking at it, you just uncover all sorts of different scenarios that, you know, as humans, we're taking in data from the world and we're making assumptions about it based upon those. And our computer is doing the same thing. That's the learning process of it. But if it learns it a certain way, there's got to be someone who learned it the same way that the computer did. So I don't know if that made sense. That was kind of a ramble, but yeah, I appreciate that, Nate. Thanks.
Yeah, ramble on both ends, just talking models for a second here. So.
Well, it's interesting to think about how IA and neural networks and things can affect our, especially via social media, affect our political discourse. But at the same time, they have a chance of balancing it, perhaps, too. If there were, you know, maybe it's not Mark Zuckerberg that's going to do that. Maybe we need an open source consortium of people to develop the AI to help us ensure unbiased political discourse as we talk about how we're going to make decisions about wearing masks or not wearing masks, or how we consider science and things like that. Maybe we need some sort of a unified government body to help us interpret that in a better way. Meanwhile, as I'm looking in the yard, I see a skunk walking across. So. But over there.
Oh my God.
but I don't know if there's, you know, the open source community is really quite active in things, but I wonder if there's an open source community of AI to help us with those types of unbiased decision making, if you will.
Sure. And I guess what I would say to that is that because that doesn't exist right now, I personally, my response to knowing that a huge percent of social media is bots is just to get my news from somewhere else. You know, I think that we as a population have gotten very lax in that we will get our opinions and our exposures to political events from people on Facebook who share things, or from advertisements on Facebook. And what that really allows us, or what we're really allowing in that situation, is to have ourselves be put into a system that someone else has created for us. You know, that a group of people have all put their hands into and spun their own way. And so I just don't think that social media has, maybe I'm a cynic, but I don't really think that social media has a clean way out of this. You know, if we had someone or a group of people that was in charge of cleaning up that mess and making it unbiased, that in an effect would also bias it a certain way. It's very complicated.
Yeah, it's interesting that, you know, they were testifying today.
Yes, I know. I thought that was interesting. I watched a good amount of it. So
yeah, and we have this, you know, split Congress trying to make these calls, and one arguing one argument and the other arguing the other. And I don't know.
it's just kind of crazy to think about how much power has been given to not only those companies, but to the information that they hold, that they feed out. So.
Mm-hmm.
And history repeats itself, you know. I mean, we went through this with Ford Motors and everything else in the past.
I've got a question from someone in the Zoom chat that said, do the computers make the neural networks, or are the neural networks created by the programmer? So what I would say about models like that, the unsupervised learning thing, is that the programmer creates a structure, a baseline for, you know, I want this many nodes, or I want this as the input and this is the output, things like that. And as a programmer, you actually are creating the data. You're cleaning it down, you're feeding it to the system the way that you want it. But then the actual network and the way that it works is determined by the computer usually. So the computer will build a system for itself and run it a million times and keep snipping off nodes and adding new ones to create the system that gives you the outcome that you told it to. So it's kind of a balance between those. Someone said, if 9 out of 10 dentists recommend a toothpaste, but they are also trying to bring in business, should we not trust them? I I don't think that we shouldn't trust the dentists. I think we shouldn't be trusting necessarily the people that are polling and pushing the answers from polls like that as marketing. I mean, marketing is a form of deception if you're a cynic like me, but there's some truth to it, but it's just also, you can torture that data and flip it upside down and poll the way you want to get what you want people to say.
So it looks like, Glenn, do you have a question?
It seems to me it's been a while now that mathematicians had come in and said that if there was a question about somebody having faked their books, that they would be able to run data analysis of like the digits that would show up in what place they're in and things of that sort. At which point they would be able to reach a conclusion that somebody was actually faking their books. Am I wrong to think of that as being a type of data analysis that was being done, at least sometime, 50 years ago or better?
So I'm not certain what you mean by faking their books. Do you mean like accounting data?
Yes, like accounting, books for somebody. So if somebody like Madoff would have had his, his records and his financial records looked at, somebody would be able to say, no, this isn't really, a legitimate set of books because, looking at the numbers, they're showing up in the wrong proportions in the wrong places and things of that sort. Like too many nines in the, the pennies position or something.
Yeah, no, so and this is a strange one to think about, and I didn't include it in the presentation, but I thought about it, is that real world random, when you think about actual random, is way different than what we as humans think. And so computers can spot discrepancies like that, where it's like, well, a human created these numbers or catered them a certain way, because it doesn't follow the actual pattern that the real world does. That can be a big red flag. I don't know that exact situation, but that sounds like a sort of a data analytics question in and of itself. I just also, I don't know the answer to that. That's very cool though. I appreciate hearing that.
Thank you.
Yeah, so one thing that was really interesting when I started reading about all this stuff this year, because I'm just constantly reading about it, but a lot of programs that are supposed to give you random, so like Pandora or Spotify or wherever you get your music, if you're a person that streams music, or if you play D&D online and you have something that rolls dice for you, or you play online games, they've sort of discovered that we as humans don't actually like when things are truly random. And so computer programmers, people that do stuff with data, have found what is like the human version of random for a lot of those situations. So when you listen to your Spotify playlist that's got a bunch of songs from bands that are the same, it'll split it up in a way that is satisfying to your brain. And I think that's kind of crazy, just because you would think that what is truly random is good, but that's not what people expect. So.
Comment, are you telling me that the online dice roller I use for my online D&D games is not accurate?
Do you use Roll20 or what do you use?
I do use Roll20, yeah.
Okay, I don't know the answer to that because Roll20 doesn't tell you, but a lot of online games don't. I think Roll20 might be different because, not just Roll20, but like D&D, just because you build the game. But as far as if you play Words with Friends on your Facebook, you're getting letters that are a situation that you would expect as random versus actually randomized letters.
So I think we can just have Dan write a bot that goes to Roll20 and rolls it, however many millions of times, so we can analyze this for Clayton and get back to him.
Thank you. Sounds good.
There was another question in the chat, and this one was asked before, which had to do with, was there an ethics component to your degree? So if you just want to answer that again quickly.
There was not. I think that I'd like to think that I am a good enough person that I can kind of see the fine lines in that, but I didn't receive that in class, so no.
I expected you to touch on the surveillance state and facial recognition, and it's been in the news a lot lately. Any thoughts about that, and where we're going and what that's going to be in 5 or 10 years?
So there was one interesting thing, and it's really strange because when I'm reading about data science stuff, specifically AI, it gets really wrapped up in the news in a way that I think it's strange because it doesn't capture truly how bad it is sometimes, but it's sensationalist in other ways. But the story that I was reading, or the information I was reading, this is like 5 years ago now, or 4 years ago, was about that airports were starting to use software that was developed for casinos, where they could tell not just like who someone was, because identification's been around for a long time, but they were being able to identify if someone had bad intentions. Basically, they could say this person is exhibiting facial characteristics of someone who's looking to do something bad today, and then they can go randomly screen you based upon that. So I think that is really crazy. And also there was a study last year, or within the last year, where they were talking about, I think some college students with a professor doing research developed an algorithm that was identifying people's sexual orientation based on their characteristics. And because we can't see those actual models, we can't know, did they base the model on pictures where people's clothing was involved, because there's like a certain culture, like rainbow or whatever, that could exhibit some characteristics that are related to that. Or if it's just simply facial recognition and about like the proportions of your eyes and things like that. So what I would say about that is I don't know enough about facial recognition. It's scary for me because we've seen all sorts of other models and programs used either with bad intentions or with negligence in a way that is damaging to our population. But facial recognition specifically, I don't know how they trained those models. And I think that they don't make that public enough that I could tell you if it's good or bad, It's just a little spooky.
Yeah, I'm guessing you're a sailor.
Based on the shirt, yes. That's a good guess.
We now know Tom's model for sailors. One thing that really kind of is sticking out to me, and I know I've asked many questions, and I'll try not to ask.
No, keep going, Nate.
Is this
ask away.
So is this idea of, I wonder if some of these things that are really being built, like based on a ton of aggregate data, like how, and sort of overall trends in some of these things, and also like generalized objectives that we're giving them, I wonder if there is like what happens to the novel things, like what happens to a novel observation, what happens to these things that don't necessarily, if we're automatically identifying stuff, it's like, how do those things play a part in this? And you can think from again, when I think about some of these computer models, I think they are just sort of extensions of our own internal human models of how we interpret things. But any thoughts about how like novelty may either be easier to identify or sort of unique things are easier or harder to identify in some of these systems? And I know that's a super abstract question, but I'm just thinking about it when I don't know. Any ideas on are these systems potentially, geared towards, I guess, not being able to identify these novel things, especially when you're like the application status set of things, like again, going back to Amazon and sort of scraping things. Like if you put somebody in there that's just way different, like how does that, I don't know, throwing another idea out.
Yeah, I think I generally understand what you are talking about, but I just don't really have an answer for you. I really don't know.
It's a better way to ask a question like that would be like, if you've got a data, like how are outliers, I know one of the things that's typical, outliers they're outliers. You can identify them based on certain things. And like the question is, I know there's even certain criteria for a given data set to identify and remove outliers from a system and things like that. And I suppose there are ways to use the outlier information as well to, I don't know, infer whatever you're interested in about that scenario. But I'm just wondering, yeah, I don't know. I'm going to be done asking this question now.
Yeah, I'm trying to think, because so what happens when we do things like linear regression is that we're squeezing our data into a specific shape before it goes in, and that involves cutting some examples out sometimes, or making inferences about what those numbers should be if they're falsified in some way, or if they aren't exactly true to what our system looks like. But things like neural networking, like there's an algorithm called support vector machine, things like that, where it's like a little bit unsupervised, a little bit less involved at the human level. I don't necessarily think that we are trimming those outliers off. They still have some outcome at the end of the day. But going back to like the Spotify example, there's this weird thing going on right now where everyone thinks they've discovered music that is just them, that they got, but there's like a kind of like a homogeneity, or like it's very homogeneous what those actual songs are. And I think, again, that falls into that we think that we're existing in a computer space that is random in some way or is specific to us. But at the end of the day, Spotify makes money from, people buying into their system, but then also record labels and things like that buying a stake in how their songs or things like that are pushed. So there's also some crazy stuff about what is becoming popular right now is really beholden to the algorithms that decide what you and I see, because there's bands and people and things like that become popular because randomly overnight the YouTube algorithm decided that their video was related to something else that was popular at the time. So I think while it's like adding chaos to the system of the universe, there might just be like, because it's chaos to everyone involved in the system at the like same degree, or to a generally the same degree, then we're all getting what is similar in the end.
I like Meets Regression. It's kind of like, and the music example is really fun to think about, because there's been examples of using AI to recreate the Beatles pop music algorithm, if you will, to randomly produce new pop songs. And pop culture in general is this homogenized thing until there's something new. And it's that novel part that I think Nate was trying grasping at, the outliers that are interesting and that people learn from, and then take it in a new direction. And then it's new enough for a while until it's again homogenized by other people following that example and things like that. It's kind of interesting to think about how that flows.
That is really interesting to think about. I mean,
yeah, that is. That's exactly right. It's like if you're being optimally fed things, based on what you've reacted to before in the past, like how much does that potentially inhibit, the advertisement that you actually want to see, like, oh, I didn't know I wanted an inflatable stand-up paddleboard, but or whatever it is.
One thing on that note that's really been kind of crazy for me to learn is that there's a ton of research that's been done about like the reward system in our brain and like what we're given and how we respond to that. And what they find generally is that when people are given a consistent reward every time, if you go to YouTube and you're like, I want a video that I want to watch, and they give you that right away and it's one you like every time, you actually come back to YouTube and spend less time on there than if they give you like 20% ones that you do not like and 80% that you do, because the reward system in your brain is expecting a reward that it doesn't get, so you wait there longer. So as far as like the homogeneousness of like being fed the things that you want, there's still always going to be this percent that you don't want, and that, I mean, it's just kind of creepy to me. I don't know.
If I could try one more time.
Yeah, of course.
You end up having talked about torturing data. Just to try and put it at a top level, do you have anything that are the 4 rules of treating data respectfully? I mean, if I can give this a context, it's like you talked about pollsters who can shape their data to, drive results in a given direction.
Yes.
And I get that. But to try and do a poll correctly is a problem that people have been dealing with for 80 years, and they still don't have it. So, I mean, what is it that you use as your principles to try and do better data analysis?
Sure. So I'm not a person that designs polling at all. Polling in and of itself is a very specific and talked about thing that people spend their, a good portion of their life figuring out how to do correctly, or incorrectly sometimes. But from a data analysis perspective, I think it's important I find it important for myself and the people that I work with to not be asking questions in a way that reflects our internal knowledge about the domain that we're working in. So I was doing a project where we were looking at wastewater runoff in the state of Minnesota into lakes from things like agriculture and stuff like that. And a lot of teams that this was like a competition, but a lot of the different teams that we were working with and working against in some ways came to some conclusions that I think reflected my own internal bias about what would be an appropriate response for the state to those runoff situations, what you would do with the soil or with agriculture in the state in general. But the real correct answer per the data was not what they had said at all. And so I think this kind of goes back to something that Nate mentioned earlier, which is that if you're someone who is coercing numbers into some information that you're trying to get for yourself or for someone you're working for, if you are looking for a specific answer, you can get it. It's more just about asking questions more broadly first about, what is true that I'm seeing rather than how is this evidence of what I already think is the truth. I hope that helps answer. I don't really, a lot of these questions I don't have a good answer to because I'm very new to this field, but I think that's my approach to it at this point. So.
Well, thank you.
Yeah, thank you.
All right, so I would say we probably have time for, why don't we do one more question here and then we'll wrap it up for the night. So does anybody have a final question for Dan that they would like to ask?
All right, can I ask a question for Dan's human side, not his mathematician side?
Yeah, sure.
All right, so those of you that know Dan, he is an amazing drummer. And those of you that don't know Dan, he's an amazing drummer. So right now, what are your top couple favorite bands right now that you're listening to?
Oh,
sorry, dude.
There's a band called Deeper. They're post-punk. And I think they're very weird. I really have been enjoying their newest album a lot. What else am I listening to? I haven't been listening to a lot of music lately. It's been interview season for me in a way. So I'm not really spending a lot of time listening to music, but Deeper is a good band. I've been listening to Car Seat Headrest a lot. I feel like most people are familiar with them. If you're not, they're good. Their newest album's maybe not that great, but that happens to the best of us. Top three. And then I've just been listening to a lot of Arctic Monkeys and Run the Jewels lately because I listen to that while I'm working out. So I guess Run the Jewels isn't a band, but does that answer your question, Clayton? Is that good?
Yeah, it does. It does. And Run the Jewels is a very topical group to be listening to right now as well.
Oh, absolutely. Definitely.
Nice. Cool. Thank you.
Yeah. Thanks everyone for questions.
Yeah. Thanks everybody. Right, so that'll wrap things up for tonight. We'll go ahead and we'll make this recording available. We've got doing the online events is somewhat new for us, and so we've started a YouTube channel. We're going to put this information up there, yeah, thanks again for everybody who came out. Huge thanks again to Dan for putting this together and taking some time tonight to chat with us about this. So yeah. So with that, feel free to log off and go about your evening. And again, thanks for coming out.
Yeah, be safe, everyone. Thanks for coming.
Don't chase.
Nice job.
Thanks for expanding my playlist. See ya.
See ya.
Yeah.
I'm gonna hang in here for a little bit. So